Thank you very much. This presentation is on vehicle controller development with CarRealTime and Simulink. In fact, I'm going to cover a number of different products from VI grade that are integrated with Simulink, starting with CarRealTime. But first, a little positioning on Simulink itself. As a tool set, MATLAB and Simulink are powerful tools used for automotive OEM design to streamline development, reduce time to market, and enhance product performance. This allows OEMs and suppliers to create virtual models of automotive components, to quickly simulate vehicle dynamics for powertrains, safety systems, and others. And it also allows you to combine in control systems, mechanical or electrical, software engineering on a single platform. So it's a very, very powerful tool being used by the industry. It's also not just for OEMs. Automotive suppliers are good customers for MATLAB Simulink, and for suppliers that enables rapid design, testing, and optimization of components and systems across the automotive supply chain. It enables the creation of virtual models of automotive systems and subsystems, reduced physical testing needs, and accelerating design iterations. And at the system level, it allows an integration of the specifics on the supplied models into a larger environment for integration, where you can do development of customized control algorithms and system components tailored to the OEM and the supplier needs, and it enhances flexibility in creating customer needs. So in a broad scope, very powerful modeling tool, and VI grade brings some solutions, actually many of our solutions, to that environment to help people that are already natively doing development there. So first I'm going to, on a broad scope, VI grade tool set offers a powerful, MATLAB Simulink offers a powerful solution for simulating vehicle dynamics and testing control systems interacting with that in a virtual environment. So we provide detailed vehicle plant models for incorporating the dynamics of the vehicle, suspension response, tire behavior, and real-world road conditions integrated into MATLAB Simulink. And then you can integrate that sort of full vehicle content with whatever control system that you're interested in running in Simulink. Beyond that, we also have a WorldSim product, VI-WorldSim, which extends the environment to allow you to model traffic, pedestrians, ADAS simulations. So extending within Simulink the ability to take your controller, put it in a vehicle, and put that in a scenario. And last, we have some tools that are specifically useful for taking software-in-the-loop models and implementing them onto VI grade provided driving simulators, so that you can get other hardware-in-the-loop and driver-in-the-loop scenarios integrated with your controller very fast and easy, without needing to actually go through a hardware-in-the-loop process. You can stay on the software-in-the-loop environment to do that. So I'm going to start with CarRealTime. CarRealTime is our full vehicle modeling tool set designed for running in real-time analysis. It's the heart of what we deliver with our simulators and real-time systems. It's a vehicle plant model that replicates the full vehicle dynamics and performance of the vehicle, allowing precise simulations and evaluation of whatever control system you integrate with it. And it's very robust, open architecture, very useful for integration on the Simulink side. So it allows that integration. And then we also have an integrated platform supporting optimization of subsystem models, and we actually provide some tools for that integrated right into the Simulink environment. So if you look at the interfaces for CarRealTime, we've got a couple of different solvers that CarRealTime supports. We have direct interfaces for all of those implemented in Simulink. There's a standard solver model, but we also have a 7-post test rig analysis tool set that you can integrate in, and we also have a max performance optimizer, which is designed for doing lap time optimization and performance of the vehicle. In addition to those, we've got just general I/O block sets for interacting between the CarRealTime model and any other aspect of the Simulink environment that you're modeling with. And then last, we've got some file system access tool for hill systems. So if I look at the interface environment, it also comes with a library of Simulink example models and tutorials. So one of the great things about CarRealTime is it's a very open architecture. It's got a number of subsystems, and then any of those subsystems can be deactivated and replaced with a Simulink version. And our library is basically, sort of a starter set of replacement. It's the Simulink equivalent of what's run inside CarRealTime. You can turn a subsystem off, turn on the Simulink version of it and use it, and then use that as a starting place if you wanted to explore and putting your own models in. If you look at the actual solver interface, it's a S-function block, and it has input and output access for basically almost all the parameters inside a CarRealTime model can be exposed into the Simulink environment. Not only exposed, but there are flags where you can deactivate and hijack and replace with the Simulink model. So very, very modular environment for that. And then if you look at it, that modular environment includes definition of all those components for a pretty light interface. And it allows direct access to all the subsystem models. In addition, the CarRealTime solver interfaces the standard sort of CarRealTime user interface for inputs, and also our own VI animator post-processor that we use for accessing all of the results of the vehicle plant model itself are completely supported when you run a Simulink model. You can just run the analysis. You can do any plotting of results inside Simulink that you want, but the output files get generated in a way that you can live even pull up our post-processing tool and get access to anything that isn't even exposed inside Simulink directly in your model. So a lot of control for doing that. And then last on the CarRealTime side is not only do we have direct integration into Simulink, but we have a broader integration with MATLAB through an API toolkit where you can, through .m and .p files, touch the input file that goes to the solver, and you can modify the model. Anything that you could do in our UI, pretty close, you can do through .m commands to grab the data, update it, push it back in, work with databases, launch models, and set up and run post-processing. So we do have a separate API independent of Simulink itself, just for MATLAB. So that's kind of talking about the strong integration of CarRealTime. We definitely have customers that run CarRealTime models through our user interface. They can run models in MATLAB through .m and .p commands, or they can run in Simulink if they want to bring in a subsystem there. And all of those work in pretty much the same way. So beyond CarRealTime, we also have a product called VI-WorldSim. And what VI-WorldSim does is it adds the environment that vehicle model is going to interact with. It extends the model for sensors into that environment, things like cameras and LiDAR sensors, radar. And it also allows you to add in traffic and pedestrians and scenarios so that a model has a rich interaction for your simulation. And of course, we have that integration fully supported in MATLAB Simulink. Not only does it add those environments, but it also is a graphics environment that will provide all of the visuals back to you as the user, but also any mounted cameras. You know, you can do it at the raw camera level, or you can do it at the virtual camera level, and it brings beyond just the ability to do it, but also environments for virtual proving grounds. We definitely have customers that have private proving grounds, and they have virtual digital copies of that they can run WorldSim and VI-CarRealTime environments on, either on our simulator or off the simulator. And we also have a virtual proving ground that VI Gray provides with VI-WorldSim that has a whole bunch of different surfaces and can also be used. And then outside of the proving grounds, there's, you know, tracks and city driving environments that are available. So as far as integration with MATLAB Simulink goes, VI-WorldSim comes with a library of interface functions to provide data access to WorldSim simulation entities. This includes being able to take all of the plant physics out of VI-CarRealTime as high content vehicle states, so that it can be interacted with the WorldSim environment that it's running in. Any simulated vehicles other than the sort of the primary plant vehicle, or we call ego vehicle, if you've got other vehicles in the scenario, you have access in Simulink to all the location and orientation of any object in the WorldSim environment that's being run. That also includes pedestrians. And then we have a sensor library with access to all the sensor outputs. So if you put a sensor like a camera or a virtual camera or a LiDAR on either your vehicle, it could also be mounted on one of the other vehicles. You could mount it on fixed objects like signs if you really wanted to, and then all that data can be exposed back into the Simulink model to be accessed by whatever either Simulink or MATLAB routines that you want to interact with. And then there's also event trigger states that you can have access to. So this extends the environment significantly. In addition to being able to sense data, we've got visualization library for the cameras, the LiDAR, and the radar that will run live with real-time updates to be exposed as part of your Simulink modeling environment. So it really does take that environment and get you into a place where you've got the plant vehicle model, and you've got a virtual environment with a track and traffic and sensors extended, so that your controller or other subsystem that you're working with in Simulink has access to that data, and you as a designer have access to it when you're using Simulink. We have a utilities library for additional WorldSim control, including things like a lighting manager, so that you can change what the lighting environment. That's really important for people that have to do stuff where how bright the scenario is affects what the camera response is, and will affect what their controller is going to do. We have some control for doing replay of previously recorded events, whether those were a physical test or some larger model that runs slower in real time, but you really want to just have that data accessed inside Simulink. You have control over the weather and the environment that WorldSim is presenting. WorldSim allows you to add in fog, clouds, rain, snow. All of that are things that can impact the sensors, and therefore the response of the system that you're working with. And then just access to input data for any object within the environment for vehicles and pedestrians and that. And then there's also some just sort of state and simulation utilities that you have access to. So that's WorldSim. and we've got VI-CarRealTime and WorldSim. But if you want to run other systems connected in, we also are driving software in the loop and hardware in the loop solutions that include software in the loop coming out of Simulink on our real-time environments. So there's a picture here of our AutoHawk 24 real-time operating system and Hill systems being connected. So there are some tools to take the Simulink model and expose data there in a way back into running in this broader real-time environment. That broader environment can include human in the loop, which is basically what our driving simulators do. So you can take the Simulink model and do integration with a software that's called Simulation Workbench that runs in our real-time environment, has access to a real-time database where data is exposed to subsystems at that level. They can come out of Simulink, they can come from other software in the loop entities, they can come from hardware in the loop, including the driver in the loop channels, but other subsystems. And then we have tool sets for working with Simulink to take models that you already have and integrate them in. So there's basically just I/O data sets that you take the exact same Simulink model that you had, whether it included a VI-CarRealTime and WorldSim environment or not, and you just are exposing channels in a way by adding these blocks in and then compiling it so that it will run in real time on our AutoHawk system. And now you've got basically the same environment that you can run in Simulink offline, and you just add in whatever data you would need to connect up to an external system, and you can compile it and expose it on an AutoHawk system for doing online on a simulator. So those are the tool sets that we have. This is just an example of one of our customers that presented at our Zero Prototype Summit last year, I believe it was, talking about the usefulness of running their subsystem model. In this case, it was a damper model tailored for customer needs, and they're running it on a simulator for doing development, but they're starting from a Simulink environment. So it's kind of just showing the usefulness for that full integration. So that's kind of a touch on the different tool sets that VI Grade has for integration with MATLAB and Simulink. If I was to say in conclusion on just that part, you know, MATLAB Simulink is a powerful modeling environment for OEMs and supplier development of their subsystems, independent of VI Grade solutions. But VI Grade solutions extend that environment to allow for full vehicle models that include all the dynamics of the vehicle, allow you to have some control over how you drive that in a pure Simulink or MATLAB environment. And further, we can extend in traffic scenarios and ADAS scenarios for that rich environment for doing your development as software in the loop inside Simulink before you maybe step over to doing it in a simulator and then eventually in actual hardware. So we provide a set of MATLAB Simulink interfaces for our products, pretty much exposed and accessible, and can be run out of MATLAB and Simulink exactly like they are through our own interfaces. And that includes VI-CarRealTime for the plant models, WorldSim for the environment, and also access to Simulation Workbench for doing real-time database and real-time hardware in the loop integration for simulators and otherwise. So that kind of sums up the solutions that we have. I do have a kind of pre-recorded demo that shows an example. So I just want to position this first. Imagine that the goal here is developing an emergency braking controller. Could be being developed by the OEM, could be being developed by a brake supplier. And the idea is they want to develop a controller in Simulink. It's going to have some information fed from other control systems on the vehicle with information about the vehicle that's in front of the vehicle this controller's on. And then the controller is going to monitor the distance and speed of based on input signals and make an emergency decision on if crash is imminent to apply a brake system. And so the demo is split up into two kind of halves. The first half is sort of from the car real-time plant vehicle model. I wanted to show how easy it is to set that up. And then on the back end, we'll cover the Simulink piece. So with that, I think we're ready to run this video. Okay, so this is the car real-time interface. We've got a plant model that's loaded. It's got a number of subsystems. Here I'm just kind of looking at the body subsystem. It's got properties of mass. It's got aerodynamic loads. There's a front and rear suspension subsystem, which has definitions of the geometry in a way that you get the K&C kind of response. You've got springs and dampers in there. There's wheel subsystems where you're basically putting the unsprung mass that gets run, and then steering and powertrain model. This is a simple powertrain model showing a torque map based off of throttle response. And then last, the brake system. This model's got a front and rear brake set of parameters in it, and also we have built-in controllers, some of which are turned off, but we left on the ABS controller. So that's the model. And now I'm going to switch. We want to get that model into a Simulink environment. So the first thing we're going to do is set up a simulation open loop that will drive the vehicle and apply the brakes in an open loop way. So there's a number of different events that you can run. This is a file-driven event, and we're basically just going to point at a flat road, and then we're going to point at a definition file for the event itself. So this is our our GUI processor for the event. This is a two-stage event. It starts with an initial conditions. So it's got a starting velocity, and the first event is basically to maintain speed. And then there's a trigger to transition to the second event. So it's just open loop saying, well, after 3 seconds, let's end the first event and switch to the second event. And that second event is coming off the throttle and applying the brakes. So if I run that simulation, and car real time runs very fast, faster than real time, and now we're going to post-process and look at that. And this is just on the car real-time side. So for this event, we're going to pull up the VI animator post-processor, and it kind of will allow you to animate it, and you can plot all sorts of signals. Here you've got the vehicle running for the first 3 seconds at a fixed speed and then braking. These are the user inputs from a robotic controller. So it's got throttle at 20%-ish for the first 3 seconds, then it switches to braking. This is the brake torque that got generated. And then in the end, the distance traveled for the vehicle. So that's an open loop event. If you're a car real-time development side, here we're running the animation of it, that we want to feed into and use as a starting place in Simulink. So to do that, I'll go back and generate a second version of this simulation. But rather than run it, what we're going to do is just write out the input file for the solver. It's basically an XML file that has all the information for the model and the event defined in it. and generates this so-called send file. And then that send file, whoever generated that, whether it was the OEM or the person doing the same company as the controller, can provide that to the MATLAB operator. So now what I've got is in MATLAB a simple script that just points to that send file, and it's going to launch a Simulink model, and at the same time it's going to launch a WorldSim process that will run in parallel with it. So we're going to run that script and we'll launch that environment. So upper left corner is, or quadrant, is the Simulink model, and then the WorldSim process is running, waiting to interact with it, and then we've got some monitors to represent. So as far as the Simulink model concerned, all we did is we added a plant input for car real time. It's just got a pointer that's pointing back to that send file with the data, and then for output, we're dumping all of the output out of the car real time model that WorldSim would need, and as input, all we're really feeding it is a maneuver ID and which one of those two maneuvers we're going to run, and we're going to allow Simulink to hijack that as the sort of first go around. From WorldSim standpoint, we put in a virtual camera. You can have more detailed cameras and do all the algorithm behind that, but this is just going to say I put a camera on the vehicle and we're just going to feed output to that of what's the distance to the vehicle in front of us. So there's a simple controller that takes that distance and calculates the velocity and the time until a collision. And in a first run, I've got this controller turned off. It's going to just monitor it. And we're going to run it in a real time, because it runs faster than real time. We'll run it in a real time way. So this controller is compiled. It's going to run. It's sending output out, and you can see in the upper right corner the WorldSim model running. And we went open loop, and at 3 seconds we hit the brakes, but it was too late. The vehicle crashed. So on the plots, it's plotting the distance to the vehicle, the velocity, the closing velocity, and the amount of time it's going to take before we collide. And also it estimates the amount of time it's going to take to brake the vehicle so to avoid the collision. So those are all channels that are available that we're monitoring. And what we can do now is let's turn the controller on by setting a flag to not be deactivated, and we'll rerun it and let the controller hijack and determine whether it's going to override the event and turn the brakes on early. So we compile it. We're going to rerun it. And now when right before the 3 seconds, it's sensed that I'm approaching that vehicle sufficiently fast that that I need to apply the controller, and in fact, it turned it on a little before 3 seconds. So that's like an example of running a subsystem controller, feeding in data that came from a vehicle model out of a virtual camera. You've got WorldSim running there. You've got the visuals for it, so you can see what's going on. And that scenario could be extended significantly beyond that. The controller could be developed, but you're doing it all in your native Simulink environment in a way that is useful and to the development engineer, without needing to go off and become a car real time expert. The control developer really just needs to have car real time installed, the libraries for car real time and WorldSim installed, and have access to that send XML file that represents the model. There was one other file I didn't really show in the demo, which defines the WorldSim environment, the fact that there's two vehicles. One of them is your ego vehicle from the view that you see, and then the vehicle in front of it was defined to run at some fixed speed. That environment could also be extended significantly if you needed to. So hopefully that gives you an idea of how easy it actually is to extend your Simulink environment to add the plant vehicle model and also add in the WorldSim scenario. So hopefully that was useful. Love to engage with anybody who's interested and would like to see more. There's some links here to our different solutions that we talked about today. For VI-CarRealTime, for WorldSim, there's also a link for DriveSim, which is our simulator controlling software that is kind of like sits on top of this environment, and also some NVH sim software.